In Module 6, Lesson 13, we're going to describe variability using what's called the interquartile range, or the IQR. Remember back to Lesson 12, the median was used to describe the typical value of our data. Clearly, not all of the data is described by that value. How do we find a description of how the data vary? What is a good way to indicate how the data vary when we use a median as our typical value? These questions are developed in the following exercises. In Lesson 12, you thought about the claim made by a chain restaurant that the typical number of French fries in a large bag was 82. Then you looked at data on the number of fries in a bag from 3 of the restaurants. How do you think the data was collected, and what problems might have come up in collecting that data? Very possibly, the data was collected by a group of people just going to the restaurant and buying fries and then counting them. And the problems that we have in counting fries, first of all, are that not all French fries are completely whole in your bag of fries. Some of them are broken pieces, and they may have been counted as a whole fry in one case and maybe not in another case. Next, if we look at the scenarios that might give us counts that are not representative of typical bags, we could say, first of all, that there may be different workers at different times of the day. So one worker might tend to put a few more fries in each bag than another. Also, some restaurants may actually weigh the bags to make sure that they weigh the same amount, but depending on the size of the fries, that weight won't necessarily have the same number of fries. If you have very large fries, you would have fewer of those than you would if they were smaller fries. In exercise 7 of lesson 12, you found the median of the top half and the median of the bottom half of the counts for each of the 3 restaurants. These were the numbers you found. Restaurant A was 87 and 5/10. That was the top half, and 77 was the median of the bottom half. For restaurant B, 82 was the median for the top half, and 79 was the median for the bottom half. And restaurant C, 84 was the median for the top half, and 78 was the median for the bottom half. The difference between the medians of the two halves is called the interquartile range, or IQR. So what is the IQR for each of these 3 restaurants? Well, restaurant A was 10 and 5/10. That is subtracting 87 minus 77. Restaurant B was 82 minus 79, which is 3. And restaurant C was 84 minus 78, which is 6. Which of the restaurants then had the smallest interquartile range? And what does that tell you? Well, comparing the 3 IQRs, clearly restaurant B had the smallest. And of course, that means that the spread of the data, as far as the median goes, is not as wide. It's a smaller spread, so the variability is less. And that will make the numbers more consistent. So we would expect when we go to restaurant B to have relatively the same number of fries in each bag that we order, regardless of what time we go or any of the other differences that we talked about in terms of how many broken pieces you have or the size of the fries, because restaurant B has very little variability. With an IQR, an interquartile range of 3, means there's only a difference of 3 from the median of the first half to the median of the second half of the data. Now our final question in number 2 about what fraction of the counts would be between the quartiles. So if we think about the data and how we split it up, so in looking at our data set, I've represented the data set in a number line format, and I put the two endpoints in. So this would be the lowest value of our data on the left and the highest value of our data on the right. The median, as you recall from lesson 12, would be the halfway point. It's halfway between the lowest half of the data and the highest half of the data. So this would be 50%, one half. The median of the first half of the data then is going to be halfway between our first value and our middle. And likewise, the median of the second half of our data is going to be halfway between the middle and the last or the ending value of the data set. So when we look at the marking for the lower quartile, remember that is the median of the first half of the data, we can see that the lower quartile would be at 25%. It'd be 1/4. And the upper quartile then would be at 75%, or 3/4. So the amount of data that's going to be in between the quartiles, if this is divided into 4 pieces, this would be 1/4 from here to here, 1/4 from this blue to the median, 1/4 from the median to the upper quartile, and another 1/4 from the upper quartile to the top value, which means that the amount between these two quartiles would be 2/4, or 50% of the total data set. The medians of the lower and upper half of a data set are called quartiles. The median of the top half of the data is called the upper quartile, and the median of the bottom half of the data is called the lower quartile. Do those names make sense? Thinking back to the drawing that we just made in question 2, hopefully that visual kind of shows you why we call them upper quartile and lower quartile. Quart, like 4 quarts. So we're going to take these dot plots and we're going to mark the quartiles for each restaurant on the graphs. And again, remember, what we're doing here is dividing it into the different parts. So the first thing I did was to mark the median for the full data set on each of the 3 distributions. Restaurant A, the median was here. Restaurant B, is right here, and restaurant C is right here. From that median, then, we know that this is the first half of the data, and this is the second half. We'll do the process again, then, to find the median of the first half of the data, or what we call the first quartile. And we would find that that first quartile, since there are 10 pieces of data, will be right here. That's our first quartile. And then our third quartile would be right here. And then remember, when we are marking medians, they're not halfway in distance, they are halfway in value. So you can see the interquartile range. This is quartile 1. And the upper quartile here. And notice in all 3 restaurants. Does the interquartile range help you decide which of the 3 restaurants seems most likely to really have 82 fries in a typical bag? Well, again, it really should. Does the interquartile range help you decide which of the 3 restaurants seems most likely to really have 82 fries in a typical bag? Well, certainly, the closer the data is, the smaller the interquartile range, the more predictable it is to find the number of actual fries in the bag. So in restaurant B, seeing how close the data is, that restaurant would be more likely to have 82 fries in the typical bag because there's not as much variability. In example 1, we'll practice finding the interquartile range. So we're going to go step by step. If something doesn't make sense to you, make a note and raise that question during a class discussion. Our data set is listed first. We need to put the data set in order from least to greatest, and this data set was already prepared for us. So that's step 1. Put the data in order from least to greatest. Step 2, we need to find the minimum and the maximum. That is the smallest value and the largest value. Smallest value is 1, and the maximum value is 17. Then we need to find the median. Since there are 17 data points in this data set, the 9th one from the smallest or from the largest will be the median, and that value is 10. Then, after dividing our data set into 2 equal parts, we're going to find the lower quartile, which is the median of the lower 50% of your data, and the upper quartile, which is the median of the upper 50% of your data. The lower quartile, Q1, will be halfway between or the median or the mean of the 4th and 5th points, because there are 8 data points before the median. 1, 2, 3, 4, 5, 6, 7, 8 data points. So our median is going to have to be halfway between 4 and 5. And halfway between halfway between the data point 4 and the data point in the 5th position. And halfway between 4 and 6 is 5. So Q1 is 5. And then likewise in the upper quartile, or the second half of the data, it would have to be between the 4th and 5th value in that second half. And that would be halfway between 15 and 15, which is 15. So our Q3, our third quartile, is 15. Next, we'll find the difference between Q3 and Q1. And the difference between them is what we call the interquartile range. So we subtract 15 and 5, and we find that the interquartile range is 10. When should you use the interquartile range? Well, the data for the 2012 salaries for the Lakers basketball team are given in the two plots below. These salaries are in hundreds of thousands of dollars. And you'll notice from our data set that the mean is just below $80,000. And then so in viewing our salaries for the Lakers basketball team, we can look at two different measures. The first one is looking at the mean and the mean absolute deviations. So when we look at the mean, we find that it is slightly below 80,000. The mean absolute deviations of the first half of the data is just slightly above 0, where the mean absolute deviation of the second half of the data is somewhere around 130,000. So it doesn't really say all that much, particularly since we have several values that are quite high in comparison to the rest of the data, meaning that this dot plot is skewed right. On the other hand, if we look at the median and the first and third quartiles, what we notice is that the median is quite a bit lower, and the first quartile and the third quartile as well are much closer to the majority of the data rather than these outliers that are quite large in comparison to the rest of the data. Now, the data are given in hundreds of thousands of dollars. So a salary of $40,000 would actually be $4 million. And a good way to show that would be to simply start off putting the dollar sign and then put the 40. Then we need to add the number of zeros that we have to have in order to have hundred thousands. So in order to have hundred thousands, we would need to have 5 zeros. So we'll add an additional 5 zeros. And then put commas in to create the actual number. The vertical lines on the top plot show the mean and the mean plus or minus the mean absolute deviation. The bottom plot shows the median and the interquartile range. Which intervals a better picture of the typical salaries? Well, as we talked about before, clearly the median and the interquartile range are much closer to the majority of the data, so they represent the data, or the typical salary is much better than the mean and the mean absolute deviation, which are thrown off, honestly, by these large values in this skewed right display. So in summary, one of our goals in statistics is to summarize a whole set of data in a short, concise way. We do this by thinking about some measure of what is typical or most likely to be seen, and how the data are spread relative to what is typical. In earlier lessons, you learned about the mean absolute deviation as a way to measure the spread of the data from the mean. In this lesson, you learned about the interquartile range, IQR, as a way to measure the spread of data around the median. To find the interquartile range, you order the data, find the median of the data, and then find the median of the lower half of the data, which we call the lower quartile, and the median of the upper half of the data, which we call the upper quartile. The interquartile range is the difference between the upper quartile and the lower quartile, which is the length of the interval that includes the middle half of the data, because the median and the two quartiles divide the data into 4 sections, with about 1/4 of the data in each section. 2 of the sections are between the quartiles, so the interval between the quartiles would contain about 50% of the data. Small interquartile ranges indicate that the middle half of the data are close to the median. A larger interquartile range would indicate that the middle half of the data is spread over a wider interval in relationship to the median.